Hello there. So this is a video continuing on tables and the CL for the teacher dashboard side of things with tables. And I've gone through some other slides in a video previous to this that kind of keeps it a little bit more basic, but things ramp up quickly here. So we're going to take a look at some more complicated examples with tables and the CL needed for the teacher dashboard only in this video. So in this question, we're looking at two linear equations on the graph. We want the student to enter in what the equation is for the line that is positive, which would be the red line, and the equation for the line that is negative for slope, and that would be the blue line. And so the correct answer here for the positive one would be y equals 3/5 x minus 2, or some variation of that. Keep in mind that some students might not go to slope-intercept, which is what I've written. Some students might do point slope form. They may, and I think it's great if they do this, they may, start putting in the change in y and then the change in x in for the slope and just leave it like that. And I really think that all of those should be acceptable. So what I'm going to show you here is how to put the CL in for this so that it'll mark it correct. So what I'm doing here after typing this in is just copying this because I'm going to need that LaTeX momentarily. As always, go into other components like here, the graph, and put read only true. And if you forget it, I've shown it in other videos as well to just sort of go back and add that in if you're seeing that you're getting a dot even after adding the correctness check. All right, so oftentimes I start off with checking something, but because this is not just a straight up number, we have to start earlier than that. We have to do some work like kind of ahead of time to think about this. And as I mentioned in one of my other videos, in mathematics, we often use functions and function notation. So f of x, g of x, h of x, and I'm going to use f meaning f of x. So I'm defining a function right now. And I'm going to not only define the function, but also parse it. So parsing it is taking it apart and rewriting it. Let me go here real quick to the documentation that Desmos has set up and parse equation. So it takes string LaTeX, like their example here, and returns an equation object, which sounds confusing, but basically it's like taking it apart and then splitting it into just the left-hand side and just the right-hand side and so on. So let's do that here. Parse equation. So it's going to ask us what equation do we want to use. And since we're going to use F as the answer key, I'm going to paste in the equation that I already wrote on the previous screen and I copied and saved for this very moment. When we parse an equation, we want to oftentimes, and we do this time, we want to take that thing that we've taken apart and split up into the left-hand side and the right-hand side, and we want to subtract so that we're using something called the difference equation, which is also defined in the computation layer. Basically, we're just saying, okay, let's put all things on one side and then have 0 on the other side, just so we have the x's, the y's, the numbers, whatever is all on one side equal to 0. So we're going to do dot difference equation, or difference function, I should say. And it's wanting me to type in here what the variables are. So the variables here are x and y. I'm just using backticks to put them in. All right, so our function f is now ready to go. So let's go back to kind of what is our objective here. We want the student to type in either that same equation that I just wrote down, y equals 3/5 x minus 2, or some other variation of that same function, and we want it to mark it correct. So if we evaluate what the student writes in, and we evaluate this answer key, the f of x function, and they get the same answers, then we will consider them the same and we will mark it correct. So we're going to create another function here, and just like we often use f of x, we're going to use g of x. And I'm going to do the same thing. I'm going to parse the equation, but this time I'm not taking the answer key, I'm taking the one that the student is writing. So the student is going to be writing their equation in this component, so I can call it this, and they're going to be writing it in, I'll show you back here, this box right here, if we're looking at the positive one. So, which is what I just made the answer key for. So that is row 1, column 2. So back here, when we say this dot, we want to say it's the content in row 1, column 2. Content of row 1, column 2. And then we want to take the difference function of that, and we are expecting that it's going to have both x and y. Again, I'm using backticks for that. All right, so just as I was explaining before, we've got the f of x, the answer key, the g of x, the student wrote this equation, and we need to check if the x and y get substituted with some numbers here, and the same x and y over here get substituted with the same numbers over here, if those match. And if they match, then we can say, good, we'll mark it correct. We should check at a few spots though, because if you just check when like x is 0 and y is 0, you know, that's not usually enough. All right, so what we're going to do at this point is check that f is our function. We're going to evaluate it, and we're going to just sort of pick some values for x. So this is our value for x, and why not go with y as being the same? This is somewhat arbitrary, as long as when I go to the g side, I am consistent. So if I use 0, 0 over there, I better use 0, 0 over here, because I want to evaluate it the same thing, because that's why they should be the same answer. And let me do a few more of these. Again, I'd rather copy and paste to just sort of save some time. And I don't know, why not make those both 1s and these both 2s? Sure. This allows me to do less writing and thinking overall, which, I don't know, maybe that's a good thing. All right, correct and check. It's very easy, like if you're doing a bunch of these and you need the code for different things, you can just like copy paste it and just do like really minimal adjustments to the code and move on. So I just want to point out that so far we've only done checking for the section of the table that asks for the positive slope equation. We have not touched upon the next one. So when I go back here, I've already set for this to be marked as true, the graph. And I've coded this so that if I have the right answer, it should show a check mark on the dashboard. And I've totally not mentioned this one at all. So we are not done yet, but let's check if this is working. Y equals 3/5 x minus 2. we got the check mark. So we know that we're in good shape. And just to show the opposite of -2, or subtract 2, I should say, is adding 2. So I could bring the adding 2 to this side, and I still get the check mark. So that shows that we can be accepting the equation in different formats from students and still know if it's correct or not. But if we put a different number here, like adding 1, then it is marked as incorrect. So it is correctly checking. We want to do the exact same thing for the negative, but this one is going to be a different equation to start off. So this one is a negative 1/5 x plus 4. So I'm going to copy this, and I basically want to do the exact same thing. So f of x, g of x, let's do h of x. Parse equation. What equation? This one that I just copied. And difference function, x and y. And let's go with I of x. Parse. And this time this is what the student enters, the cell content of the second one down, which would be row 2, column 2. And we want to take the difference function of that one, and we are expecting an x and a y from the student as well. So now that we've got that set up, we just want to do the checking for it. All right, so it's no longer 0, 0, oh, sorry, it's no longer function f, it's function h here, h and h. And over here, it's function I, and I. And I don't really need to change anything else. It should be ready to go. So let's go up here, and y equals 3/5 x minus 2. Y equals negative 1/5 x plus 4, and it works. And again, you can switch this around to be in different formats, but the positive answer should always be the first one. The positive slope should always be the first equation, and the equation with the negative slope should always be the second one entered, the bottom one. In our next video, I'll talk about setting it up with a lot of flexibility here for the student.